Well, this is great. It's wonderful to see a full room. So there's a lot to talk about, and I have a tendency to run a little bit long, so I'll count on somebody to stop me, because I won't stop otherwise. And the question we're looking at is, do we have free will? We saw this in the little introduction. I'm also aware that I'm just the first act for Lavender Witch, so I'll try to strike a compromise between speaking too long and leaving the floor to this wonderful group that I'm excited to see. So let's begin with this iconic decision-making situation. I hope you've all seen The Matrix. I have a colleague who told me the other day I was teaching a course at ULB and none of the students had seen The Matrix, so he didn't know what to do. So I hope some of you have seen the movie. So Neo chooses the red pill. Could he have chosen something else? Could he have chosen to not take any pill? Could he have chosen to take the blue pill? What shapes this decision that he's making? Is it a free decision? And what does one mean by free decision? Those are questions that are about free will. And it's an ancient question. Already in medieval times, people were thinking about what does it mean to have free will? And if you look back at the work of Thomas Aquinas, for instance, you see that at that time, there's two different acceptions of the word or the expression free will. One is the intellectualist interpretation, which puts forward our capacity to be aware of the consequences of our actions and hence to exercise our intelligence when we make choices. But there's also a voluntarist interpretation, which is more Anglo-Saxon. It's about free will, and that emphasizes that we are masters of our will, through which we can overcome our desires and thus act freely, that is, without being slaves to our passions. But in both cases, however, the crucial idea that remains is that we are capable of changing things through our choices. So what makes a choice a free choice? And here I can appeal to the work of Christian List, who lists 3 criteria for free will. We'll say that an action is free if and only if it is intentional, that is appropriately supported by an agent's intentions. This is not the case, for instance, for this carnivorous plant, Dionea muscipula, the Venus flytrap, which, as you will see, captures this insect for further processing, by which I mean digestion later on. What's going on here? We're not willing to ascribe any consciousness to the plant, and we're certainly not willing to hold it morally responsible for the death of the insect, right? Nobody is going to make a, put the plant on trial. It didn't have the intention to kill the insect. In fact, once the insect has touched 3 sensitive hairs on the surface of the leaf, of the leaves of the trap within a certain time frame, then it's inevitable, right? The trap closes and the insect is digested. So certainly didn't have the intention. So this wouldn't qualify as involving any sort of free will. Now, if you look at this amazing robot, Atlas, built by Boston Dynamics, which at some point was bought by Google and then sold again, but they make these amazing machines that were completely unthinkable just 20 years ago or so. Here, we sort of sense agency. We have the impression that it's going through the motions, so to speak. But again, we don't recognize consciousness. There's nothing it is like for Atlas to be Atlas. And we don't have the impression that it intends anything. It's just doing this. The way we interpret what the plant does, what the robot does, appeals to the idea that they have internal mental states. We know that this is wrong, but we cannot help but interpret what we see as a function of mental states, and this is something that the philosopher Daniel Dennett called the intentional stance, which we apply even to completely abstract situations such as this one, in which we see these animated shapes interacting with each other. There's 2 triangles, a circle, a rectangle. This is all cartoonish, it takes place on a screen, and yet we cannot prevent ourselves from interpreting this as though they have mental states. But of course, there's no mental states, there's no intentions. we see agency here, and so free will and responsibility perhaps where there can be none. We are sort of aware of this, but we cannot prevent ourselves from attributing intentional states to those agents. Second criterion, it must be possible for the agent to do otherwise. This is called the principle of alternative possibilities in philosophy. Again, there's the plant, same story. The action of the plant was inevitable after the insect had animated or stimulated those 3 hairs on its leaves. It couldn't have chosen at the last moment to spare the life of the insect. So again, no free will in the case of the plant. But think also of Eichmann here at his trial after the war in Jerusalem, or what's called now the Nuremberg defense, where people claim I was just obeying orders, basically. Could they have done otherwise? Yes, perhaps, but they were also under coercion, basically. And so here's a case where, again, one wonders the extent to which there was free will in the actions of the Nazis in this case, but also in many other cases. And this is where those issues, these fundamental issues about free will, connect with the notion of moral responsibility. Under which circumstances are you willing to attribute responsibility for somebody's actions? You probably remember the experiments by Stanley Milgram in the 60s, where there was this situation where Milgram was actually instructing participants to stimulate an actor who was pretending to suffer as a result of receiving electrical shocks, with a cover story that this would promote learning. And Milgram famously showed that about 2/3 of people who are under this protocol actually go through and end up stimulating, well, actually shocking the actor to an extent that was described as dangerous. Again, do they have free will? Well, their actions are, they could say no, but most don't. And so this shows you that what we choose to do is determined by a host of factors, including the social context. This is my postdoc, Émilie Gaspard. She's just published an amazing book called Just Following Orders, in which she describes these kinds of situations, Milgram-like situations, and she's trying to understand how people disobey orders that one gives to them. I worked with her, on the replication of Milgram experiments, which we managed to do with adaptations to the design that made the experiments ethical, in particular symmetry. If I shock you, you shock me, in the next part of the experiment. And we showed that despite what people say, I was just following orders. This is rhetorics, it doesn't, you can be suspicious about what people say. But we show that in this Milgram situation, when you're obeying somebody else's orders, you're actually, there's neural evidence that you're actually feeling less responsible, which shows that sometimes when people say, I'm just following orders, well, this is correct. They're actually feeling less responsible. In a further experiment, we also looked at what people who give the orders to the participant feel. What do they feel like? Do they feel responsible? Because they're giving the orders. They're not executing them, but they're giving the orders. But the person who executes the orders is not imagining the orders. She's just pushing on the buttons. Well, in that situation, we end up with diffusion of responsibility. And sadly, nobody feels responsible anymore, right? The person who gives the order doesn't feel responsible because he's not executing the orders. And the person who's following the orders doesn't feel responsible either because she's merely executing the orders. All right, third criterion, the action is under the agent's causal control. This excludes cases like this. Somebody has an epileptic crisis while driving. The car veers off, somebody is killed. Who is responsible? Is the person responsible? Well, no, because what happened was not under the person's causal control. It's a sad story, but the person was not responsible. Now, in the courts of justice in America, there's more and more cases coming up where people invoke this situation where, well, it wasn't me, it was my brain, right? Because we find a tumor in the person's brain and so on and so forth. This is becoming a sort of locus of debate about what we should do with all these cases. For instance, in the case of an epileptic crisis, you could argue, well, the person, if she was aware that she was epileptic, did she take her medication? Why was she driving under the possibility that she might undergo a crisis and hence lose control and so on and so forth? Very complicated questions that we only have a little bit of time to touch upon. So that's free will. You have an intention, you can do otherwise, you have a choice, and then whatever you do is under your causal control. Now, List, whom you see depicted here, discusses 3 challenges that people have put forward to question the very fact that we have free will. One is the challenge from radical materialism, as he calls it. The second is a challenge from determinism. And the third is a challenge from epiphenomenalism. And we're going to look briefly at all those 3. So the challenge from radical materialism goes as follows. The first premise is free will requires intentional agency. You need intentions. Premise 2 is as follows. Scientifically speaking, there's no such thing as intentional agency. This notion is a leftover from folk psychology and premature versions of scientific psychology and will eventually be dispensed with in favor of a completely neuroscientific theory of human behavior. So conclusion, scientifically speaking, there's no free will. And you read a lot of stuff about this. This is called eliminative or reductive materialism. That is the notion that agent-level accounts of choices can always be reduced to sub-personal accounts involving, for instance, neural predispositions. This is the story, it's not me, it's my brain. So we read things like dopamine determines impulsive behavior, genes affect political orientation or sexual orientation, symmetrical facial features indicate a healthy upbringing and hence good genes, and that's why we choose people with symmetrical faces, because they're indicators of fitness, and so on and so forth. In other words, we're systematically deflating agentic level explanations of what people do and substituting those explanations with things that limit the scope of intentional behavior in humans. In philosophy, you have perspectives like illusionism, epiphenomenalism, reductive physicalism. We're not going to go through all of these. Hard determinism. That sort of push on the scope of your consciousness, so to speak. Same goes for psychology. So many people have talked about what we can do without awareness, how our brains can be manipulated by subliminal messages, and so on and so forth. There's also, in the study of consciousness, a strong focus on identifying the neural correlates of consciousness, but this has nothing to do with what it feels like as a subject. And then, of course, now there's AI that, again, sort of limits the scope of what makes us human. Because ChatGPT can write an email better than you, and AlphaGo can beat the best player and the world champion at the game of Go. And so this machinization of society is a problem. I'll go back to that later. But what happens is that the place of man in the universe shrinks with every scientific advance that we make. Of course, Copernicus showed that, well, the whole universe doesn't revolve around the Earth. Darwin showed that we're just cousins of apes and don't occupy a special place in the tree of life. Freud showed how many of our decisions are taken without awareness and driven by unconscious desires. And then Turing comes along and shows that, well, computers can be much smarter than you are. All right. So that's the challenge from hardcore materialism, basically. You can account for everything based on a sort of reductive materialism that leaves out higher level explanations. The challenge from determinism goes as follows. Free will requires alternative possibilities among which an agent can choose. But if the world is deterministic, that is, if the past fully determines the future, well, then there are never any alternative possibilities, because all actions that we can carry out are predetermined. And so the conclusion is, if the world is deterministic, there is no free will and no moral responsibility. This is what the Swiss philosopher Bernard Barchi expresses in his book about neuroethics. He says, physical determinism excludes free will, and the only way to keep the latter would be to deny the truth of contemporary physics, which is a rather expensive price to pay. And I think he's right in saying that it's a very expensive price to pay. Searle says the same thing, since nature is made up of particles and the relationships between them, and since we can account for everything in terms of particles and their relationships, there's no room left for free will. Mitchell calls this physical predeterminism, and it raises the specter that if indeed we can predict everything from one moment to the next based on the location of every elementary particle in the universe since the Big Bang, then it may turn out that we're just spectators to our own existence. This was predicted. You thought you had chosen to come here, but you didn't. It had to happen that we're all here together. And so, is this true? Well, it certainly doesn't feel true, but that doesn't tell us much. When I talk to physicists, disappointingly, they always avoid the metaphysical questions. They say things like, well, you have to do the experiment this way, and then you observe, and you get this sort of data. But, you know, what came before the Big Bang? That's a sort of question that they wouldn't answer. Is it the case that everything was planned out, so to speak, and unfolds unimpeded since the Big Bang? Is also a question that few physicists are willing to engage with. Some physicists have developed this theory that's called the block universe. So we think that we're moving through time, so there's a past, there's a future, and now it's the present, and it's constantly moving forward. So this concept of the block universe is really strange, right? Everything is fixed. We're moving through time just as we're moving through space. The past, the present, and the future, they all coexist simultaneously. I think, I don't know, we should ask Stefan maybe, but I think few physicists would agree with this, but I know there's a community that defends this idea of a block universe. Spinoza, surprisingly perhaps, was also a hardcore determinist. Here's something he wrote, and I'm not going to read the whole thing, but it begins this way. Every singular thing or anything which is finite and has a determinate existence can neither exist nor be determined to produce an effect unless it is determined to exist and produce an effect by another cause, which is also finite and has a determinate existence. And again, and so on and so forth ad infinitum. So he endorses a form of the block universe while defending freedom, which he distinguishes from free will. Complicated philosophical story in which I'm not going to go, but that's the story. So, third challenge, the challenge from epiphenomenalism. The first premise is free will requires an agent's causal control over his or her actions. Those actions must be caused not merely by non-intentional physical processes, but by the relevant mental states, and specifically the agent's intentions. Second premise, scientifically speaking, anything an agent does is wholly caused by non-intentional physical processes. The agent's intentions are at most byproducts of the underlying physical causes. And so, scientifically speaking, there's no free will. Now, again, a philosopher, Jaegen Kim, who passed away a couple of years ago, I think, who defended this causal exclusion argument, according to which if all physical effects have sufficient physical causes and no physical effects are caused twice over by distinct physical and mental causes, there cannot be any irreducible mental causes. What does he mean? Well, here is Daniel Wegner, a social psychologist, who defends the same story, but from a psychological perspective. He says, well, assume I have the intention of calling my friend. So this is a mental state, I have an intention, and then I carry out an action, which is picking up the telephone to get in touch with my friend. Okay, so fine, we have two mental states. Mental state number one, the intention. Mental state number two, the action itself. If you believe that everything that goes on in your mind can be reduced to brain states, Then, of course, there's a brain state number 1 that causes the mental state number 1. And then there's a brain state number 2 that causes the mental state number 2. And Kim's exclusion argument amounts to say, well, once you have made the link between brain state number 1 and brain state number 2, the link between the mental events becomes redundant. You don't need to explain the same sequence of actions by 2 different causes, one mental and one physical. So this mental link that you make between an intention and its action, its subsequent action, is a form of illusion. You don't need this. That's what they want to say, the causal exclusion argument. And here's Wegner's own rendition of this. You have a thought, you have an action, you experience this conscious will, I'm willing this action. There's an apparent causal path, but this is all an illusion. What actually happens is that the thought has unconscious causes, the action itself has unconscious causes, and those are the actual causal paths with the links between those two. And what you experience as conscious will is just an illusion. All right, there's many philosophical positions about free will. Here's a brief overview of them, and rest assured we're not going to go through them. But you can be a determinist. You believe in the block universe, everything is programmed from the Big Bang. You can be an indeterminist. You say, no, there's indeterminacy at the level of elementary particles. That makes you a libertarian, basically, about free will. If you're a determinist, you can be a hard determinist. There's no free will at all. You can be a compatibilist. You believe there's a way of accommodating free will within a deterministic universe, and so on and so forth, all the way down to modest libertarianism or daring soft libertarianism. I have no idea what those positions are. Or the Valerian model, or the impossibilism, but philosophers know. So, all right, what do they believe, philosophers? This is also an interesting question. There was actually a little survey carried out by David Bourget and David Chalmers, asking about 2,000 philosophers in renowned institutions what their perspective on free will is. And as you can see, about 60% of them are compatibilists, so they believe the universe is deterministic, but free will is possible within this deterministic universe. About 14% are libertarians, so they exclude compatibilism. They say if the universe is deterministic, there's no free will, but I don't believe the universe is deterministic. 12% say there's no free will, period, and then 15% say something else. Now, if you know this, compatibilists, well, for them, free will is an illusion. For the libertarians, free will stems from chance, which doesn't give you free will, actually. If you make a choice that is driven by randomness, this is no more satisfactory than if your choice is entirely determined by the history of the universe. And this flashing is intentional, by the way. It's meant to induce a specific hypnotic state in the audience so that I can speak for the rest of the evening. And then the no free will guys, well, they're pretty clear about their perspective. There's just no free will. So that doesn't leave much room for actual free will. In this context now, what do the neurosciences tell us? Well, we all have the impression that we're the stewards of our own actions. This is a small statue by Jan Fabre, the Belgian artist. But actually, a lot of what the neuroscience people have tried to show is that it's the opposite, basically. It's our brain that guides our behavior. Is there any neuroscience evidence for this? Well, there's the famous studies by Benjamin Libet, who was an American neurophysiologist. And he set up this famous experiment where, well, basically we're looking at voluntary actions. So he takes a person in and he tells that person, at some point in the future, you will move on a voluntary basis. Just when you feel like it, you will move your finger up. You will make this voluntary movement. It's voluntary because it's not driven by a response to an external stimulation. It really comes from people's intentions, right? So people have to lift their finger. That's the entire experiment. But they also have to monitor where this little dot is on this display, which looks like a clock, basically. And they have to notice where this dot is when they first have the urge to move. So they haven't moved yet, but they feel like they're about to move. This is going to happen now. They have to indicate in other conditions where the dot is when they actually move. And then while they do that, you also record muscles activity. This is something called the EMG. So you know exactly when the person has moved his finger. And then you also record with electroencephalography something called the readiness potential, which takes place over the motor cortex in the middle of your skull. And this tells you that the brain is getting ready to execute a movement. It's an area of the brain which is called the supplementary motor area. And this gets active, and you can detect this with electroencephalography, when the brain is preparing an action. Now, you realign everything, and then this is what you see. This is the time that people move. EMG indicates that the finger has moved. This is the moment that people say that they have moved. So as you can see, they make an error. They think they move a little bit earlier than they actually do. This is the moment where they report, I'm about to move. I have now made my decision. It's going to be now. This is 200 milliseconds before they move. But look at this readiness potential, which indicates brain preparation for action. This starts ramping up 500 milliseconds before the person actually moves his finger. So you look at this and you think, well, what's going on here? The brain actually moves before the person becomes aware of having the intention to move. Notice that it couldn't be otherwise if you believe that whatever happens in your mind is driven by what's going on in your brain. There's no saw that tells your brain, now it's about to move, and programs the brain so that it does the relevant actions. So it has to be that way. But what's surprising is that it gives us the impression that, okay, the brain decides to move, and then at some point in the future, 300 milliseconds later, you as a subject is being told, hey, you're going to move. And now think of this as your intention. And then you're actually moving, right? And this completely reverses the story that we have about ourselves. Is it true? We'll see later. There's complications with this. But so this is the problematic period, right? Everything that happens before the moment that people say they feel like moving. This is another experiment that was like Libet's, but updated for a better imaging method, a better brain analysis method, which is functional magnetic resonance. People sit in the scanner, and now the decision is, do I push left or right? Again, it's a voluntary decision. They do whatever they like. And they have to monitor which letter is on the screen and memorize it and report it, again, in these different conditions. So when they have the intention to move, to choose, when they actually choose, and so on and so forth. And then what the authors did is use machine learning, basically, to train a neural algorithm to analyze the brain images produced while people were choosing where they will push, left or right. And they trained this algorithm to try to predict what the decision would be, right? So can an algorithm be trained to figure out, based on images of your brain, to figure out what decision you will actually take, push left or right? And as it turns out, this works with about 60% accuracy, but more importantly, up to 7 seconds before the person makes the decision, right? So based on brain activity 7 seconds before people actually report having chosen, you can tell with this algorithm, based on analysis of the brain images, whether the person will push left or right. It's pretty striking. This same experiment, but now with abstract decisions. So people have to decide, they see numbers, they have to decide, do I add them, do I subtract them? Same story. 8 seconds before, you can say, he's going to choose to subtract the two numbers now. And it goes further. This is using the same methods, an illustration that you can reconstruct what you're thinking, actually, based on brain activity. So again, people are in a scanner, they're watching movie clips, which you will see on the left. We're recording brain activity. Actually, I wish I had done that study, but it's not me. We're recording brain activity, and then we're training a neural network to reconstruct the visual experience that a person had based on the brain activity. So all the algorithms see is what's going on in the metabolic changes in the brain of the person watching those movie clips. Look at what it does. It's not perfect, but this is today. Think of what we can do 50 years from now. It is doing quite well, sort of hallucinating what the person might have seen just based on analysis of what's going on in that person's brain. It is striking. And so the last bit of our private life, what is going on in our minds, seem to be, well, subject to deconstruction and to reconstruction by means of artificial intelligence, basically applied to those images. So very striking. And so all of this induces, I guess, the idea that, oh, well, we're nothing but the activity of our brain, right? Is the mind then truly nothing more than the activity of the brain? And certainly there's a lot of people who think that. There's famous books, including Jean-Pierre Changeux's. I don't know if anyone has read that book when it came out. I did, 1983. Neuronal Man, L'homme neuronal. Like there's nothing else, right? The mind is entirely nothing more than the activity of neurons. Okay, fine. But one argument that you can put forward against this view is, of course, that the activity of the brain is itself nothing more than the result of lifelong experience with the world and other people. We learn all the time, and perhaps we learn to be conscious as well. And there's plenty of evidence for this brain plasticity and the fact that every experience that we go through is etched into the biological activity of the brain. The only reason why you will, I hope, remember something from what I'm saying now tomorrow is because I'm actually modifying your brains with my words. This is actually what is going on because I'm leaving a biological trace in your brain. So maybe it isn't so frightening to think that everything that goes through your mind is driven by what's going on in your brain if you accept the idea that there's a loop and that everything that goes on in your brain is also the result of your experience interacting with the world and with other people. There was a funny story carried out in London comparing taxi drivers and bus drivers. Why? Well, we're looking at the hippocampus, which is a region of the brain that codes for the memory you have of navigating space, but also the memory of everything that happens to you, which is called episodic memory. But so it's about space, and space is what taxi drivers and bus drivers do, but there's a crucial difference. Bus drivers always follow the same trajectories through a city. Taxi drivers have to solve spatial problems every ride. They have to figure out, how do I get there, and so on and so forth. Their hippocampus is larger, right? They have a bigger hippocampus. You don't even need to use sophisticated methods. You can just do a plain MRI. Doesn't need to be functional or anything. It's an anatomical MRI and measure the hippocampus. It's bigger in taxi drivers because they have such extensive experience navigating space. Here's an even more striking demonstration of the plasticity of the brain and the fact that every experience leaves a trace. This involves epileptic patients who cannot be treated by substances, basically, so they have to undergo surgery. And of course, you want to tell the surgeon, you cut this part out, which is the epileptic source of the crisis. Those are neurons that fire abnormally. You take those out, but you take nothing else out. And so how do they do that? Well, the patient gets into the hospital. They get implanted with electrodes deep in the brain. So it's a very invasive procedure. And those electrodes can record the activity of a single neuron. And so they sit there, and then the staff waits for a crisis to take place. And then with what the electrodes record, they can infer where the crisis originated, and so tell the surgeon, you have to remove that bit, but nothing else. All right, in one experiment like this, because it's boring, so some of these patients accept to work with cognitive psychologists, was a really simple experiment. They just flashed hundreds of pictures to these patients, famous people, family, unknown persons, and so on and so forth. And in one of these patients, they find one neuron, one single neuron, that only responds to Halle Berry. When the patient sees a picture of Halle Berry, that neuron fires, right? It doesn't fire in any other circumstance. So in that person's brain, there's a Halle Berry detector. In another guy's brain, they find a Bill Clinton detector, right? What is so striking about this? There's two things. One, nobody expected that single neurons could encode such high-level properties. Of course, it's not the one neuron. It's part of a larger network that represents the memory of Halle Berry in that patient's brain. But the really striking thing is, of course, that this can only be attributed to culture, right? Evolution didn't install Halle Berry detectors in our brains. This is something that a patient learned and was interested in during his lifetime. So this is a sort of direct demonstration that culture gets into your brain. So I think we're continuously involved in these predictive loops, basically. The brain is redescribing its activity to itself. It's learning to do that in the service of carrying out better actions. And it's also interacting with the world and with other people. And this forms a system of meta-representations by which the brain redescribes its own activity to itself. So it's like the machine, your brain, creates a virtual representation of itself, a model of itself, so to speak, that has agentic features that cannot be fully reduced to the machine that produced it, right? And it's this interaction which is so interesting. So let's look at those three challenges again and figure out, well, do they hold, basically? Can you use those challenges to exclude the possibility for free will? Radical materialism. Well, does it even make sense to analyze human behavior in terms of elementary particles? That doesn't make any sense. Elementary particles don't have meaning, there's no information there, and so on and so forth. What do we gain, in fact, by reducing everything to sort of biology, but perhaps even lower to physics or chemistry? Here, I think there's a confusion between the substrate and level of analysis. Of course, everything that goes through your mind has to be based on the biology of your brain. That doesn't mean that you can reduce everything mental to the biology of your brain. Just like the fact that temperature cannot be fully reduced to mean, well, it can be reduced to mean molecular kinetic energy, but it doesn't mean that temperature does not exist, right? It's entirely caused by interactions between elementary particles, so it can be reduced to it, it's caused by it, but there's a further fact about temperature itself. What about determinism? Well, even physicists disagree about whether the universe is fully deterministic or not. We don't understand this, right? Think of quantum mechanics and so on and so forth. Note, as I said earlier, that it wouldn't say free will to say that our decisions are driven by randomness, basically. It's no more satisfying to say my decisions are fully determined than it is to say, well, there's chance and I'm choosing at random. But even if the universe were fully deterministic, it may be the case that freedom emerges at higher levels of description. And here I'm again appealing to Liszt, who in his little book called Why Free Will is Real, has this very interesting levels of description account of these issues. He says, well, look, we look at elementary particles. Here's time, time 1, time 2, time 3, time 4. We're in a deterministic universe, and so if I know where these elementary particles, let's say it's electrons, if I know where these elementary particles are at time t plus 1, then I know exactly where they will be at every subsequent moment. I can predict exactly what's going on. That's what it means for physics to be deterministic. And so each of these particles follows a deterministic trajectory. But now let's take a step back and merge what's going on here into larger cells. And so these trajectories then merge. I'm moving up the hierarchy from physics to chemistry to biology to psychology. And now I have this situation where the same deterministic particles produce trajectories where choices emerge. And so this is really interesting, basically, because it suggests that you cannot fully reduce what's going on here to the level of those deterministic trajectories, right? So you gain some freedom by going up levels of descriptions. And I think in this entire area, there's a confusion between the functional basis of things, the substrate, so in the case of mind, the brain, and the functional contribution. What do those higher level states, what you think, what you believe, contribute to the actions and the decisions that you make? So there's this loop between lower levels and higher levels of descriptions. And of course you may say, well, how can something be its own cause? You know, this doesn't make any sense, in fact, right? But if you think of it as taking place through time, then I think we have exactly the sort of relationship that we're interested in, where what happens at time t, at time t1 influences not the very biology that causes things to happen at t1 in your mind, but what happens in your mind at t1 influences the biology of your brain at time t plus 2. Here's another rendition of this. This is what is going on, right? Brain state number 1 causes mental state number 1, which is a global state of this super complicated system that is the brain, and that global high-level state influences, in turn, what's going to happen in your brain at the next moment. And there you have not this loop, but this spiral over time. Demonstrations that your beliefs and everything that you think influence your decisions is to be found everywhere, but this is a particularly interesting experiment because it has the implication that even if you think everything is deterministic, which is a compatibilist perspective, it's still better to believe in free will. And so in this experiment, what they had were people who had to read a short passage of text defending either fully deterministic perspective, or by contrast, a fully libertarian perspective, right? So 2 passages developing arguments, and surprisingly, both passages came from the same book by Francis Crick. But so people do that, and then they're given mathematical equations to solve, and they're told, you will gain a monetary reward as a function of how many problems you can solve. And then here comes the trick. The experimenter says, well, I have an emergency, I have to leave you, but you can solve the problems by yourself. The money is in that box. And then, I trust that you won't cheat. And then, of course, what is going on? And the answers are there too on a different sheet. And so it turns out that the people who read the passage about, well, everything is deterministic, you're not responsible for anything, cheat more than the other people, right? So believing that your actions are fully determined by the past and that you're never responsible for what you do actually leads you to sociopathic behavior. Final challenge, epiphenomenalism. It is a person's intentional mental states that are normally the difference-making causes of the person's actions and not the underlying states of the brain and body. This seems obvious in a way, but people who defend this epiphenomenalist perspective about the relationships between the mind and body sort of would like this not to be true, but the difference-making states are states that belong to the agent, not to the elementary particles that we're all made up of. And another kind of argument against this idea, where you say, well, everything that happens in the mind I can account for by the brain, well, then physicists come along and say, well, you biologists, everything that happens in the brain I can account with protons and neutrons and electrons and so on and so forth. And then, guys working on quantum physics say, well, no, it's all about bosons and muons and quarks, etc., etc. Where does it end? We have no idea. What is the ultimate level at which causal relationship actually takes place? So Kim's causal exclusion argument, in fact, really cannot hold. And now you may say, well, what about Libet? Well, as it turns out, this pattern that we saw, where the brain prepares the action way before you actually feel you're making the decision, there's a very interesting literature now questioning this interpretation of Libet's experiments, because it may be the case that this slow ramping up potential action preparation as an artifact of the way that successive trials in these Libet experiments are accumulated, basically. So it may be artifactual, and perhaps the alternative explanations as saying, well, neuroactivity, there's noise, it fluctuates, and you're going to make a decision when it crosses a particular threshold. And that means that there's no longer this long gap between the moment the brain begins preparing for action and the moment that you're actually experiencing the decision. It's still your brain that causes your intention, in a way, but you don't have this delay, this bizarre delay where you have the impression that it takes hundreds of milliseconds before you become aware of an intention. In fact, the two events occur simultaneously. So, how do we get there? Well, we're not born agents with free will. We learn to become agents, and we learn to become agents in part through evolution. There's two books that just came out, and for those of you, and I hope many of you are interested in these questions, they couldn't offer a starker contrast. One is called Determined, A Science of Life Without Free Will. It's by Robert Sapolsky. And then the other, and they came out almost together, is called Free Agent by Kevin Mitchell. And here they are. You can see them debating each other. On YouTube, this is Mitchell, this is Sapolsky. I'm not going to talk much about him because his book is less interesting than I thought. Mitchell's book, on the other hand, is very interesting because he tries to defend free will by proposing an evolutionary story about it. And so he says even biochemical systems that are not alive undergo energy fluxes, and then we can go to cells that sort of make decisions. They're not decisions, but there's a membrane that separates your inside from the outside, and molecular movement between the inside and the outside. And then we move to simple organisms that have a nerve net here, and that can make a little bit more adapted decisions. And so there's a whole hierarchy of organisms. And what he wants to say is that, first of all, by looking at evolution, we can build an evolutionary story of the development of free will. Simple organisms have very limited choices, basically, but they can act in a way that promotes their fitness. More complex organisms like ourselves have a lot more choices. Dennett has a similar story. Dennett, who sadly passed away a few months ago, in Freedom Evolves, one of his great books, he distinguishes between four kinds of creatures in the same spirit as Mitchell. Darwinian creatures, basically, they try out things, and then that either succeeds or fails, and then those that do the right things survive by natural selection. So there's no thinking of any kind there. Then he calls the next step Skinnerian creatures that can learn by testing actions in the external environment rather than trying things at random. So they can ask themselves, well, what do I do next? Then we go to Gregorian, Popperian creatures who can pre-select possible behaviors. So they can try things out internally, and they can ask themselves, well, what do I think about next? And then there's us and other complicated organisms, which he calls Gregorian creatures, which are characterized by the presence of culture. We have words, we can exchange tricks and tools, and we ask ourselves, how can I learn to think better about what to think about next, right? So it gets loopier and more complicated, but that's how freedom evolves, basically. Dennett asked this great question, I think, about this, which is, how do we go from doing things for reasons to having reasons for doing things? Many of the simpler organisms do things for reasons that were installed by evolution, but those are not those creatures' reasons of their own. We have reasons to do the things we choose, because we have mental states, we're conscious, and so on and so forth. An earthworm does the things earthworms do, probably just for reasons that are set up by evolution that do not depend on the worm's internal states, and its wishes, its desires, and so on and so forth. Dennett, by the way, is a compatibilist, so he believes the universe is deterministic, but he also thinks that there's a possibility for freedom in a deterministic universe. And he says the following: freedom is the ability we have to realize what is valuable in different circumstances. It is the capacity we have to make intelligent choices, that is, choices informed by experience. Paradoxically, he says, free will is only compatible with a deterministic universe, that is, a universe in which one can predict the consequences of our actions. If the universe was truly random, then whatever you choose to do wouldn't guarantee anything, right? You could die on the spot because a meteor falls through, and so on and so forth. It's only in a universe that is sufficiently deterministic that you can learn how to exert your intelligence so as to make adapted choices. Barchi, and I'll finish with this, says something similar. He says, for my part, I would propose a form of deflated compatibilism. There are two planes and two concepts of responsibility and of freedom. On one of these planes, the issue of free will and physical determinism plays out. On the other, different determinisms are at work, amongst which neuronal determinism. So he says, well, there's the big metaphysical issue. Nobody has an answer to that, not even physicists. We don't know if the universe is deterministic or quantum, what are the implications of these. But that's a metaphysical issue. But then there's the question of the many determinisms, neuronal determinism, but also social determinism, and many other sources of constraints on the choices that we make, and those we can think about in productive ways. So, to conclude, if it will stay there, we're not free to go against the laws of physics, despite the fact that we feel like it, right? Think of this situation where we state, he could have done otherwise, he could have made a different choice. Well, probably, if we could imagine rewinding reality, that is literally, this is impossible, but it's a thought experiment, but if you could rewind reality, you would probably make the very same choice that you did the first time, right? If everything is the same, and you're facing exactly the same situation, and all the elementary particles of the universe are in the same configuration, you would make exactly the same choice. When we say he could have done otherwise, we're not thinking of the same person doing things differently. We're thinking of a different person actually making a different choice. That makes a lot of sense, but that's a kind of freedom that we don't have. We cannot change our mind at the very last moment, right? We're constrained by the laws of physics. But we are free to make intelligent choices, which is, as Dennett said, paradoxically possible only in a sufficiently deterministic universe that one can learn in and from. Free will comes in degrees. This is the evolutionary story, and there are many determinisms. So this freedom that we have is a biological freedom. I'm nothing but the activity of my brain, but crucially, the activity of my brain is nothing but a biological inscription of my experience with the world, with myself, and with other people. Living organisms are what philosopher Hans Jonas called a locus of concern. Things matter to them in a way that nothing matters to elementary particles. That's the level of description that we should be most interested in. So understanding free will and human agency, I think, are urgent philosophical problems. We're working on this in my team. I think consciousness matters. It's high time that we regain a sense of agency, I think, in a world that becomes increasingly algorithmic. And so regardless of whether the universe is actually deterministic or not, I think, just like Dennett, that we should believe that we are free and act like it. But I think there's also many interesting arguments to defend the idea that we actually have freedom, that freedom is not an illusion, that through the levels of description, there's something that emerges that makes it possible for complex systems like us to actually make decisions informed by their intentions, with causal control over their actions, and in a way that reflects the possibility of choice. And with that, I'm finished. Thank you.